Good morning, everyone, and welcome to the 18th episode of Tech Talks. Joining us today for this very unique episode is Mr. Subheesh PV, Manager Application Technology at ExxonMobil Company India Private Limited. He has an experience of 14 years in the rubber and plastics industry and has presented in leading focus groups and industry seminars such as Indian Rubber Expo, National Rubber Conference, and many more. ExxonMobil is the industry leader in almost every aspect of energy and chemical manufacturing process. They have adopted themselves with the changing times and now working towards offering state-of-the-art EV solutions. As we are shifting from internal combustion vehicles to electric vehicles, such shifts are also being witnessed in the subsystems of a vehicle where we are on the never-ending path to optimize their performance and ensure that they become more sustainable. Hence, the topic for today's session is innovation in EV cooling, shift from EPDM to TPV. We look forward to this interesting and insightful session and welcome you, Mr. Subheesh, on behalf of Team Gyaniki and today's participants. Welcome, sir.
Yeah, thank you. Thank you, Shashwat. So let me share my screen.
Yes, sir.
So good morning, everyone. First of all, let me thank the Gyanki team for giving us this opportunity today to present in this forum. So I'm very glad today to share some of the innovations that ExxonMobil Chemical has done in EV space, especially on the battery thermal management system. As some of you know, may know that in the EV coolant hoses or in the IC coolant hoses, EPDM rubbers are predominantly used. So EPDM is ethylene propylene monomer. However, we are currently seeing a shift from this EPDM rubber to a highly engineered material called thermoplastic vulcanizate or TPVs. This is exactly where ExxonMobil, with its flagship product called Santoprene TPV, has a role to play. So in my presentation, I will be covering about Santoprene TPV, the value that it brings to this industry, and especially in the EV coolant hose application. So let us look at some market trends here. So on the left-hand side chart in 2017, we can see there was about 1.1 billion vehicles on the road. And out of this 1.1 billion vehicles, 3 million vehicles falls into the category of electric, plug-in, and fuel cells. So this number is further going to increase by 2040. So we will have about 420 million vehicles on the road, which falls into the category of electric, plug-in, and fuel cells. And this is majorly driven by the decrease in the battery prices, some of the stringent norms that the government is going to bring in terms of the tailpipe emissions, the efficiency that people get by switching over from IC engines towards the electric vehicles, and also it brings energy independence for the oil importing countries. Further, if you look from a regional perspective, we can clearly see that Asia Pacific region leads the global electrification drive, especially China. China is the leader here. And also India has a major role to play because by 2040, we expect to see a lot of electric vehicles on Indian roads as well. So moving on, so this slide shows a simple evolution of the automotive industry from past to the present and from present to the future. So from past to present, there were a lot of incremental changes in the design of the automotive industry. But from present to future, we see a radical transformation. We are essentially changing from the IC engines towards electric mobility, and it has a lot of consequences on the kinds of part that are being used, that are to be used in the automotive segment. So this is where ExxonMobil company like ExxonMobil has a lot to offer in terms of innovative solutions for this automotive industry. Now let us look at what are the needs and the corresponding solutions that the stakeholders are looking at for the future mobility trends. So first is the decarbonization. So how do we achieve decarbonization? It is very simple. We use lighter weight parts in the vehicle, and combined with the latest technologies, we can uh, we can achieve energy efficiency. And another thing which is very important is the circular economy. The OEMs and governments are trying to achieve this. So this can be achieved by using parts which can be recycled uh, very easily. So this will reduce the waste generation in the in the environment, and at the same time it will reduce the carbon footprint. Also, there is a push for using post-consumer recycled materials in the manufacturing plant while producing the raw materials. This will further reduce the waste generation and reduce the carbon intensity. Finally, from an emotional level, more and more customers are considering themselves as passengers and not as drivers of the vehicle. So this brings in the need for a cabin which is very comfortable and which have very less NVH like noise, vibration, and harshness. So to achieve all this, we need to do away with old age-old elastomers like EPDM rubber, and we need to look at more engineered products like a TPV or thermoplastic vulcanizate. So this slide forms the core of my presentation. Here I'm going to introduce the product named Santoprene TPV. So Santoprene TPV is in the market for more than 40 years, and even in IC engines, this material is used widely, especially on the weather seal parts, the window weather seals, which is shown on the slide. So most of the OEMs have replaced the EPDM rubber, and they are currently using Santoprene TPVs. And this is even more important for an EV vehicle because in EV, lightweighting matters a lot. So the lighter the parts used, the longer the range of the vehicle. So materials like TPV are very, very critical for electric vehicles. However, my session will mostly cover about EV coolant hoses, and Santoprene TPV has a greater fit in EV coolant hose application, and I will be covering in detail about that. Okay, so what exactly is Santoprene TPV? So Santoprene TPV was invented with a simple concept in mind to deliver a ready-to-use product which can perform like a rubber, and at the same time, it can be easily processed like a plastic material. So this is the atomic force microscopy of Santoprene TPV. It is a morphology here. So you can see here that we have rubber, cross-linked EPDM rubber, which is dark in color, and this is encapsulated in a polypropylene matrix. So this forms a locked in morphology, and this gives superior properties to Santoprene. Superior properties like long-term sealing performance, long-term aging resistance, long-term weathering resistance. So these are very, very critical parameters as far as an automotive industry is concerned. Now let me talk a little bit more about the material chemistry of an EPDM compound versus Santoprene TPV. So on the left-hand side, you can see an EPDM compound. So EPDM compounds essentially has a lot of raw materials, starting from a rubber, EPDM rubber, CBs, carbon black here. Then we have oil, fillers. So a lot of things needs to be mixed. So it is a compounder dependent. So it is near to impossible to achieve consistency in an EPDM compound. And the OEMs are never sure uh, that what they are asking, whether they are getting it back from the compounders. So it is very difficult to trace back the composition of the product in EPDM compound. So here is where Santoprene TPV brings in the element of transparency for the OEMs, because we sell our products by grade name. So a grade sold in US or a grade sold in India will have the same properties, and it is very easy for the OEMs to check what is the material used in their vehicle. So again, TPV has EPDM rubber, then it has PP, which is polypropylene, and there are a lot of other chemicals as well. But we maintain the batch to batch consistency of the products. Also in the market, there are a lot of uh, other TPEs. So TPEs are thermoplastic elastomers, and Santoprene TPV, Santoprene thermoplastic vulcanizate, falls under the category of TPEs. However, all the TPEs are not Santoprene TPV. So Santoprene TPV are superior performing materials which can perform in the longer term. Like I said, long-term sealing performance, long-term aging, long-term weathering resistance. Whereas there are other TPEs like styrenic-based SEBS, TEEE, which is a copolyester, or PVC NBR. So these have different properties, and they don't give the long-term performance which is given by Santoprene TPV. That is a basic difference. So now let me talk a little bit about the TPV hose design and the material selection. So a hose, most of you might be knowing a hose. There is a cross section given here on the screen. So the hose has three layers, basically an inner layer, followed by a reinforcement layer and an outer layer. So each system or each layer has a particular function and has a material requirement which is needed to meet those functions. So for example, the inner layer should have very good sealing function because the coolant is conveyed through the inner layer, and it should also be resistant to the coolant. And the middle layer, which is a fiber reinforcement layer, gives strength to the hose, and it should meet the burst pressure. So the hose should not burst while it is in operation. And the final outer layer, it is a protective layer, so it should have very good abrasion resistance. So Santoprene, with its broad product portfolio of more than 100 grades, can meet these requirements very easily. So moving on to some more advantages in terms of design flexibility of Santoprene hose. So you can see on the left hand side, we have an hose made out of EPDM compound. So here again, we have an inner layer, a reinforcement layer, and an outer layer. And EPDM compounds need to be vulcanized or cured. So this is a process where the part is subjected to heat and temperature, and you essentially give strength to the part. So this is a highly energy intensive process, and the EPDM compounds or EPDM hoses are not recyclable. And whereas if we go to the right hand side, we have PA or PP hoses. PA is polyamide hose and PP is polypropylene hose. So these are very hard hoses, and the major problem is that it leads to the NVH concern. So there is a concern on noise, vibration, and harshness if you use this kind of hoses. Also, the PA hoses have high water or glycol permeability. The coolant permeates through these hoses, which is not desirable. And if we choose a TPV solution, there are multiple options. Uh, uh, there, sorry, I'm hearing some background noise. If you may mute. Okay, thanks. Okay, so in the TPV solution, there are three choices. Uh, we can either use a reinforced TPV hose, or you can choose a monolayer hose, or we can also go for a multi-layer hose where we can bond the Santoprene TPV with other engineering thermoplastics like polyamide or polypropylene. So in all the cases, we achieve significant weight reduction. We achieve higher line speeds. See, Santoprene hoses are recyclable. That is very, very critical. Uh, then we can also go for design optimization where we can reduce the wall thickness. So there are multiple options and multiple advantages of using Santoprene TPV in the hoses, in the EV coolant hoses. Okay, now this slide talks about the processing of an EPDM hose, EPDM coolant hose, as well as a TPV coolant hose, and how TPV is a better choice. So first, let us look at an EPDM processing. So EPDM processing, as I said, it includes a lot of raw materials like an EPDM rubber, a carbon black, oil, fillers. So you need to mix all these things in a mixing unit. Then the compound needs to be extruded to give a shape. And after extruding, you need to go for a knitting operation and then a covering operation. So after all these operations, what you get is a hose which cannot be used. It needs to be cured or vulcanized. So vulcanization it's a long process. It's a energy intensive process. It takes a long time, more than 40 minutes. And finally, you get the hose, EPDM hose. So this is a batch process basically. And in each process, you generate a lot of scrap which cannot be recycled. So since it is a batch process, a lot of manpower is also involved. And finally, the cost of making the hose goes up. So now if you look at a TPV hose production, it is a very simple process. TPVs are ready to use pellets. Directly take those pellets, put it in a thermoplastic extruder, do the extrusion, knitting followed by the covering operation, and you can easily shape it via mantle shaping or thermoforming process, which is less time consuming. Finally, you get the part out. So the line, the footprint is very, very small compared to an EPDM line. It is only 1/4. And also the investment cost is very less. So EPDM line costs 3 times higher than a TPV line. So if somebody wants to invest a new line to make a hose, the answer is very, very clear from this slide. So TPV is the cost effective solution and it saves a lot of money for the investor. So now let me talk a little bit about the Santoprene TPV hose properties. So we have commercialized Santoprene TPV hoses in EV coolant hose application. And as most of you may know that it is very difficult to commercialize a product in the OEMs. So in this example, we have commercialized our grade 10180, which is about 85 Shore hardness, and it has a reinforcement of PET. And the idea of the hose is about 18 millimeter, and there are a lot of requirements to be met to qualify this hose. Requirements like fluid temperature. So we need to meet the temperature requirement from -40 to 100 degrees C. Burst pressure is again a critical requirement. It should be greater than 10 bar for this application. And the hose should not burst while it is in operation, because hoses are very critical for an automotive, because the hose, if the hose fails, essentially the vehicle will come to a standstill and it is not desirable. Then vacuum collapse is again another requirement. Hose should not collapse during the operation. Leakage should not happen. The leakage of the coolant should not happen while in operation. And these vehicles might be shipped to other countries, cold countries. So low temperature flexibility is also very critical. At low temperature, the hose should not crack. And while during the assembly, the hose is connected to a connector, so the assembly force needs to be less, whereas the pull-off force should be very higher. And you can see the Santoprene TPV easily meets all these requirements, and that is how we could commercialize the hose at the OEMs. Okay, now I will talk specifically about the long-term coolant resistance of Santoprene TPV, because at the end of the day, the hose needs to convey the coolant and the material used should be resistant to the coolant that is used. So we have aged Santoprene in this coolant for 108 degrees C for 2000 hours. It is a pretty long duration. And we tested a wide range of hardness from 70 Shore A till 41 Shore D. We tested 5 grades, and we tested properties like the mechanical properties like hardness, tensile, elongation, and also the weight change and volume change to see the resistance of Santoprene versus the against the coolant. So clearly we can see that Santoprene is not aging in the coolant, and the higher hardness grades like 87, 84, and 41 shows better aging in terms of the hardness, volume, and weight changes. So very minimal changes are observed even after the long-term cooling, long-term aging in the coolant. So this is a very interesting slide here. So this puts a comparison of Santoprene TPV versus other materials which are used to make the hoses like an EPDM rubber or polyamide 12, which is seen in the industry. So clearly we can see that the total system cost of making an EV coolant hose with Santoprene is much cheaper than an EPDM and a PA12. And coming to the hardness range, so Santoprene has a very broad hardness range from 60 Shore A to 40 Shore D. That means hose can be used to make the Santoprene can be used to make hoses which are softer as well as which are harder. Whereas EPDM plays in the softer hardness range like 60 Shore A, and PA12 hoses are very hard, 70 Shore D and above. Also, there are a lot of other factors like the density. The density of Santoprene is very low. It is about 0.96, whereas an EPDM compound is very, very heavy. So the density is 1.2, and it adds to the weight of the part made out of EPDM. And EPDM, one of the major disadvantage is it is not recyclable. And going forward, everybody is looking at the sustainability angle. Everybody wants a circular economy where parts need to be recycled. So this is not possible with EPDM. That is one of the biggest drawback of EPDM rubber. And whereas if we look at a PA12 hose, it has very poor permeation resistance. So the coolants permeate through these hoses. The NVH properties are also not good. Uh, so there will be a lot of rattling and the noise inside the cabin if we use PA12 hoses. Yeah, so moving on. So let me give an example or a case study wherein we converted an EPDM coolant hose to Santoprene hose by doing some design optimization. And you can see here the EPDM hose with a reinforcement was about 294 grams per meter. And when we did the design optimization here, we could reduce the wall thickness because of the properties of the Santoprene. We reduced the wall thickness from 3.5 millimeter to 2.4 millimeter. So finally, the weight came down to 169 grams per meter, keeping all the meeting all the requirements. So we got approximately 40% weight reduction by converting from EPDM to Santoprene TPV. So this is a huge number, a big number when we look from an EV angle. And this we could achieve because of the lower material density as well as by applying the design optimization while converting the hose from EPDM to Santoprene TPV. So this is a classic example where we achieve a lot of efficiency, we achieve weight saving, we achieve the cost saving as well. So before I show some of the commercial cases, let me show the comparison of Santoprene TPV EV coolant hoses against EPDM as well as a polyamide hose. So when comparing with EPDM, the major advantage is the weight reduction that is possible. We can significantly reduce the weight of the part by using Santoprene TPV. Uh, as well as the cost reduction, we can also save a lot of cost by switching over from EPDM process to Santoprene TPV process. Santoprene TPV has excellent abrasion resistance, and it also has very good chemical resistance and electrochemical resistance, which is very important for EV coolant hoses. So Santoprene TPV also offers long-term performance, like long-term durability. So one of the issue with EPDM rubber or EPDM hoses is that after a period of usage in the service temperatures, the chemicals or the materials used in the compounding starts to bloom or starts to come out of the surface on the part, and this leads to hardening of the EPDM part, and it leads to cracking, this is very common in the EPDM industry, and this does not happen with Santoprene TPV. This is a very one of the major advantages of TPV over EPDM rubber. Now, if we look at the comparison with polyamide, so polyamide hoses are very stiff, uh, very very stiff hoses. So flexibility is not possible with polyamide hoses, whereas Santoprene hoses can be made flexible as well as stiff. So we have the choice. So Santoprene TPV has excellent NVH performance, low noise, vibration, harshness. It has very good hydrolysis resistance for the coolant hose applications. There are a lot of connection options. We can use either clamps or quick connectors, whereas polyamides, we have to use quick connectors, which is again a costly affair. And the total cost reduction possible is around 25% by using Santoprene TPV in place of a polyamide hose. So this clearly shows that Santoprene TPV is the material of choice for EV coolant hose application, considering all the properties and all the superior performance that it offers to the segment. Yeah, now let me show a commercial case here, because Santoprene TPV is not new to the industry. So this is not a new thing that I'm bringing to the table. So Santoprene has been in the market for more than 40 years. And it is being used in the internal combustion engines to make a lot of parts. And here for EV coolant hose application, we commercialized the hose in this OEM named Neo, which is a Chinese EV vehicle manufacturer. And this hose goes into these two models, ES8 and ES6. It is working well. And we are also discussing with a lot of other the OEMs, and there is a lot of progress happening, and there is more to come as well. So this was about the commercial case which I wanted to share, and let you know that the Santoprene TPV is a material which is proven in the industry in various applications, and this is a new addition which we have brought in to the industry, which is the EV coolant hose application. Okay, I think with that, I would like to conclude my session, and I would like to thank all the participants and the Gyaniki team again for your patient listening and for giving us the opportunity. And if you would like to connect with us, my contact details are given here. Also, you can visit us on the website santoprene.com or exxonmobil.com to more about our products and offering to the market. Also, we are active in the social media. You can follow us on Twitter and LinkedIn. So thanks, and thanks again to all the participants.
Thanks a lot, Subheesh. And is it okay? Can we roll into some questions?
Yeah, sure, sure.
Okay. So I believe the first one, and I think there's one of the participants also, audience in the audience also has brought this up. Are there any sort of limitations to this from a design or a sizing perspective? I see you've gone for a specific size of hose. I'm guessing that's probably to replace what's already existing. But are there any limitations there?
No, there is absolutely no limitations. We can go to hose in a diameter as small as like 0.4 millimeter or 5 millimeter. You can extrude the parts as thin as 0.5 millimeters. So there is no limitations. And in fact, this is the advantage of Santoprene TPV, because you can go you can make parts as thinner as possible, which is not possible with an EPDM compound. With EPDM, you need to meet or meet a minimum thickness, for example 2 millimeter or so, to meet the requirements, whereas Santoprene can go down as low as 0.5 millimeter.
Fantastic. Okay. And sort of a follow up to that is as far as the manufacturing process itself is concerned, right? I mean, it's sort of pretty similar between the two, but from achieving from an accuracy standpoint, right, or deviation or tolerances, how well does that stack up?
Yeah, the Santoprene TPV is known for the tight tolerance that it meets, especially in extruded compounds or injection molded compounds. You don't see a very large amount of shrinkage or swell in Santoprene TPV, unlike the EPDM rubber, which swells and shrinks much bigger than Santoprene TPV. So tight tolerance is easily possible with Santoprene TPV. So this helps to save a lot of cost to the OEMs, because they can make parts which are tighter in tolerance. They don't have to give an additional cushion or additional material in their processes, which will further increase their cost structure. So tight tolerance, yes, which is always possible with Santoprene.
Okay. Okay, I do apologize. These questions are going to fly pretty quick because I think they're pretty like short questions. I hope that's okay.
Yeah,
My next one is to do with we mentioned the very major benefit of recyclability, right? Whether
yeah.
that's EVs or even existing ICE vehicles, that's a major advantage. Can you just tell us more about the recycling process? Maybe just highlight on a bit, and what sort of efficiencies we are looking at when it comes to being recycled.
Okay, so I will talk about Santoprene TPV recycle,
Yeah.
especially on a hoses. So the hose process is basically a continuous process, and, during the process there is a break, like we have to go for a knitting process as well. So in each process, if you see the scrap generation in Santoprene TPV, those scrap can be taken and that can be regrinded again, and that can be reused with a virgin Santoprene grade. So we typically request customers to blend in the ratio of 80-20, 80 virgin and 20% recycled. And this, and we have done extensive tests in our lab where the virgin Santoprene grades were recycled more than 10 times, and still it behaves like a virgin material even after recycling for 10 times. So that is amazing. So At the end of the day, a person using Santoprene TPV in the process will generate no scrap. So everything can be recycled by regrinding and reusing.
Okay. All right. So let's take a few questions from the audience. I think they're pretty similar to what I was about to ask, actually. The first one is, have you conducted any thermal stress analysis, at 108 degrees C or higher? It's a very specific
So
question, actually.
yeah, I think we have done the pressure volume and thermal analysis, and we have done that in our from a third-party lab. Uh, so right now I don't have the results to share here, but we have done that cyclic thermal cyclic testing as well. Yeah.
Okay. Next one is from Sanchit asking, what is the dimension and weight change after coolant aging and subsequent drying? So I'm guessing it's probably sort of a use case thing. Uh, any changes in the, you know, uh, from compared to original when it comes to uh, aging, basically, I believe.
Okay, so aging by aging means coolant aging because I have shown
Yes.
this slide. Yeah, so the changes are minimal. So if you see from a hardness perspective, the changes will be like 2 units change after coolant aging of 2000 hours, and even the tensile strength will be less than 20%, 20% change after aging, which is very minimal. So long-term aging, whether it be coolant aging or heat aging, the change with respect to the original and the aged sample is very minimal for Santoprene. So unlike EPDM, EPDM the change is more and it hardens and it cracks. So that phenomena is not seen with Santoprene TPV. So that is the advantage.
And when it comes to, right, for now, the focus is on coolant hoses, but we also understand that TPV is very well used in other areas of the vehicle as well, right? It's basically trying to replace EPDM wherever,
Yeah.
in a lot of other areas of the vehicle. So, from that perspective, does it have any limitations when it comes to working with other forms of other types of fluids, or is that not a concern?
No, as I mentioned, Santoprene is in the market for more than 40 years, and it is
Right.
used extensively in the automotive industry. So more than 65, percent of the our material goes into the automotive segment, and we use Santoprene parts in the weather sealing applications, the suspension bellows, the rack and pinion boots, the air ducts inside the vehicle, the plugs, bumpers, and grommets. So a lot of parts in the vehicle are made out of Santoprene TPV. And coming to the resistance to the fluids, it is very well resistant to brake fluids. It is resistant to some greases, lithium grease, and only limitation is that it cannot withstand the hydrocarbon oil. So it can take splashes of oil, but it cannot be used as a dip application in the hydrocarbons in the oil. So that is the only limitation. All other aqueous solution, alkali bases, it is resistant.
Sorry, can you highlight a bit more on the when you mentioned hydrocarbons in the oil? So you're saying that it is probably not suitable for um, cooling hoses that may use oil as
No, no.
lubricants? No.
Yeah, if you are using hydro
Carbon
hydrocarbon
hoses.
oils like
Yes.
hydraulic fluids,
Hmm.
uh, in such cases, Santoprene is not suitable to convey the hydraulic fluids. But the
Okay.
coolant, it is resistant, no issue.
So this is why they are even more suited to EVs than ICE
Yeah, right.
applications, right?
Yes.
Because absolute, yeah, okay, makes sense. Okay, so Pradeep from the audience has one more question. In TP, he says that in TPVs, is there a chance of plastic breakage in the area of where the twist clamps are usually tied to, right? He says that, of course, anywhere where there are twist clamps or any clamping that is in the coolant formula.
There is a lot of
Just
background noise.
I think there's
As
some background noise. Just one moment.
yeah, yeah, yeah. Okay. So Can you
Yeah,
please repeat
go
the
ahead.
question? I couldn't hear it.
Yeah, sure, sure, sure. So Pradeep says that in TPV is asking if there is any chance of a plastic breakage, especially in the areas where hose clamps may be used, because of course there is going to be some slight bit of deformation wherever we have any clamping force going on the hose. So is that something that is a concern?
No, so far we have not come across such issues, and Santoprene TPV is more like it behaves like a rubber, like an EPDM rubber, and the advantage is that it can be processed like plastic. So the clamping, there is a particular clamping force which are required to clamp these hoses, and I don't uh, expect that people over tight these clamps in a way that it really breaks or collapses the hose. Otherwise, if you apply a proper clamping force, then there is no issue of the plastic breakage or collapse of the hose, which will happen. Because even the Santoprene, in general, it can work from -40 to 120, which is the service temperature of a coolant hose application. So it can easily take those temperatures, and it doesn't soften at these temperatures. So I don't see an issue with that.
Okay. From a at a vehicle level, right? So we know it's um, used, like it's been used for a long in use for a long time now. And if we were to, and this is a sort of a ballpark number I'm asking, if you were to use this for a EV application where pretty much it's replaced all the sealants, or as well as hoses with TPV, what sort of weight savings are we looking at from and just at a ballpark level?
Okay, so I mean there are a lot of different kinds of vehicles in the market. There are SUVs,
Right.
sedans. So
We
yeah,
can
so
take,
yeah,
I mean, the percentages
okay,
should probably
okay. So
still
I will
be.
take a
Okay.
example of a sedan, and
Okay.
um, typically there will be around 15 kg of EPDM rubber which is used in a sedan kind of
Mhm.
vehicle. And if you replace all these parts with Santoprene, you can easily achieve a weight reduction of somewhere around 4 to 5 kgs. So for an EV vehicle, this is significant, huge. Even
Right.
for IC, it is significant, but EV again, it is much more significant. And coming to the hoses, the number of hoses that are used in EV vehicle is 3 times higher than IC engines. So again, this again, it is a very important factor here. So why
Right.
we should use TPVs.
All right. Okay, I think the questions will keep coming. So I'm going to take one last one from the audience, right, for the day. From Niranjan, how do you recycle multi-layer hoses containing Santoprene? Multi-layer.
If the multi-layer hoses are made out of polyamide or materials which can be recycled, which can be recyclable, then it is easy to recycle because all these things can be regrinded and then reused. But however, if you have a fiber in between, then we need to take it to a recycling center, and then you will have to separate out these layers, the reinforcement layers, and then do the recycling of inner tube and outer cover of Santoprene separately. So that recycling facility needs to be there, and that is requirement of the future for especially for a country like India, where we need to segregate, and we should have the proper facility to recycle the parts. Yeah.
You,
So,
you
so,
bring up a
uh,
good point. Sorry,
so,
go ahead.
sorry, yeah. So, Subhi, they want to understand whether we can. I believe my understanding is whether they can co-extrude all the Santoprene layers, or they have to do it one by one. This is what the question is. How do we do multi-layer extrusion in Santoprene TPB?
Okay, so multi-layer extrusion is already done in the industry, in hose industry. We have multi-layer hoses, which includes the polyamide inner tube, and then we do the covering of Santoprene on top of the polyamide, and we also have a binding layer in between, a compatibilizer layer in between, which can bond Santoprene with the inner layer, the polyamide layer. So multi-layer extrusion is simple. We need to have the facility to extrude multi-layer, multi compounds, and with that, it is possible. So there is no issue, which it is already done in the industry. A lot of fuel tubes are multi-layer tubes.
Okay. So Niranjan, do we answered your question, or you have any further query to this?
I think Niranjan's question was to do more with the recycling part of it,
Okay.
not extrusion part of it.
Okay.
Just we have to ask people to mute. Yeah, thank you. Niranjan, would you like to unmute yourself and just speak up? I guess Subheesh did touch upon the recycling process, but maybe if it wasn't answered, maybe you can just speak up.
Yeah, am I audible now?
Yes.
The basic question is having co-extruded the multi-layer hose and then it goes for recycling, which contains the polyamide inner layer and the binding part in between and the TPV outer layer. I mean, it cannot be just put into shredder and shred it into pieces and then put it back to recycling because it has dysfunctional layers of in the pieces. So in such cases, is it necessary that the individual layers have to be stripped and then recycled, or how?
Yeah, if we wanted to use those parts into again a new virgin santoprene grade, then stripping would be one option because you have to strip the cover, outer cover, and then you need to shred that separately. But then again, it becomes a cumbersome process. But if you
Mm.
want to use into non-functional applications where all the three layers are recyclable, like polyamide is recyclable, santoprene is recyclable, then it is now you can do the regrinding together and then use it in a parts which are not functional, so which do not have
Into
functional
a
requirement.
molded component or a non-critical
Yeah, something.
molded component.
Yeah, correct. Something like
Mm.
that.
Because when there is a compatibilizer layer in between, like for example, I worked on Westamid in the inner layer, then you have a binder, and then you have the TPV on the outer.
Yeah,
Typical industry converters are there who have done the fuel lines. So their always
yeah.
complaint has been even when they want to shred it and then try to
Okay.
recycle it. The binding, I mean, you cannot so easily strip the individual
Yeah,
layers because
yeah, yeah,
the compatibilizer holds the
yeah.
two layers so firm that it's
Hmm.
virtually impossible to strip.
Yeah. So there is one more option. Like we have certain products called XLR, which is again a compatibilizer, which can be recycled. So this is a solution that we offer to our customers, wherein they can use this. Now if they want to use polyamide layer, they can go and use that. Otherwise, they can use a lower hardness santoprene grade, followed by XLR compatibilizer if
Mm.
needed. Uh, and if it is an outer layer is a polyamide, then compatibilizer is needed. Otherwise, we can use multi-layer of santoprene grades with different hardnesses, so which can be easily recycled and it can be used in a functional part as well. So there won't be an issue.
Yeah,
So we need
correct.
to, I mean, change the way the industry is currently working. We need to look for parts or raw materials which are recyclable, which can be blended with other materials as well. So if all the industry people start thinking in that way, then the recycling process will become very easy. We will not have much of a challenge.
Yeah, these options will evolve over a period of time.
Yeah,
The
correct.
necessity has come.
Yes, sir. Correct.
Thank you. I'll mute
Thank you.
myself now.
Thank you, Niranjan. Okay, Subheesh, I think I'm going to just round it off with one last question. The overall ecosystem itself, and from a sourcing supply chain perspective, is this something that's all pretty much, and from India perspective mainly, is that all in place already, or is that something that's still being set up from, having a local setup uh, for this product?
I mean, we have two plants manufacturing santoprene, which
Okay.
is one is in US and one is in UK, and we have a distributor overseas polymers in India, located pan India distributor. So if you
Mhm.
have any requirement for this grade, you can always contact us directly, or you can contact overseas polymers. So they will be able to help you.
Okay. Okay. Fantastic.
Sir,
Yeah.
I
one
think
last question regarding. Sorry to interrupt you, sir.
go
One last
ahead.
question regarding what is the life and what are the warranties you are giving for this hoses actually?
So the warranty is given by the tier one. So we are raw material suppliers. We supply the raw material to the tier two or tier ones. Tier one makes the part and they supply to the OEMs. So it is a tier one who gives the warranty of this of the whole part, uh, and the raw material supplier do not give the warranty. However, this material, the shelf life of the material is, if properly stored, it is more than 10 years, and it is not a material that will degrade within one year or 2 years. So this product was invented itself to perform for the longer term requirements. So like we have data which shows that the material do not degrade at 150 degrees C for 7 days and 135 degrees C for 1000 hours. So I don't think there is any issue from a raw material standpoint. And the warranty wise, yeah, it should be given by the tier ones, and they can easily give the warranty for the life of the vehicle, I would say. And there is no issue expected because of the raw material.
And
I hope it
also,
answers.
your PPT mentioned regarding the clamping force and clamps regarding the width of the clamps also. So,
Yeah,
is it necessary to have that clamps, particular clamps, and these clamps are also provided by the tier ones with the hoses, or
yeah,
other
yeah.
commercial clamps are viable for this hoses also?
Yeah, generally the OEMs or the tier ones do the clamping. They can choose, they can either use clamps or quick connectors. So that option is available with Santoprene, whereas it is not available for the PA hose, as I have shown. So PA needs a quick connector, but Santoprene hoses can use any clamps with the varying dimensions. It could be 15 depending on the size of the hose, and it is provided majorly by the part supplier or the tier ones to the OEMs. No specific
Okay, thank you
requirement
very
is
much.
there for.
Okay, thank
Thank
you
you.
very much.
Okay. All right. Before I close it out, just a quick. I see some participants are about to leave, or some already have. So I just want to make a quick announcement that once we pretty much end the session, we are going to walk you through Gyaniki and what it's all about. I even request Subheesh, if possible, if you would like to stay back for a while. It's probably just going to take 10 minutes, and Shashwat is going to walk you guys through that. In the meanwhile, Subheesh, I um, thank you once again. It's been a great session. We love having folks and sessions where things are addressing different parts of the industry, and from the sort of questions that you've been getting, I'm pretty sure that people are interested, and so all in all, thank you for the presentation. Thank you for taking the time, and yeah, I hope we can stay connected. Any
Yeah,
any
yeah,
any
yeah.
words from you? Yeah.
I also would like to thank all the participants because it is Saturday. Most of them might be having a holiday today, and you took out the time to attend this session. So I'm very thankful on behalf of the company, and also to the Gyaniki team for giving us this opportunity. So thank you very much.
Absolutely. Thank you.